Alright, in this video we're going to explore the idea of elasticity and its impact on total revenue. So before we even get into elasticity, we got to understand the concept of total revenue. And total revenue is a concept we are going to be using in the next 3 to 4 chapters as we look at behaviors of the firm. And if you think of total revenue as the dollars that a business generates from the sale of its good or service. So pretty simple formula to understand it. If you take the price of each individual unit and multiply it by the quantity demanded, or the quantity that you sold, right, you're going to get your total revenue, or the total dollars coming in. So total revenue is price times the quantity demanded, or price times the quantity that a business sells. So we're going to look at how this total revenue, or the dollars that come into a business, changes in response to the elasticity of demand. And remember, elasticity is just a measure of responsiveness. On a very simple level, it's how will consumers change their behavior when prices change. Right? That's what elasticity is looking at. Remember, if demand is elastic, right, elastic is going to be more responsive to change than the price change. For instance, a 10% increase in price, will lead to a more than 10% decrease in the quantity demanded. The law of demand always holds true as well. Price goes up, quantity demanded is going to go down. If it's inelastic, it's going to be a relatively, less of a change in the quantity demand. So if price, decreases here by 10%, we're going to see an increase in less than 10% of the quantity demand. All right. So as we get into revenue here, right? So as price decreases, so we're looking at a price going down. Okay, so as price is going down, and we decrease price, if demand is elastic, meaning it is more responsive to price change, okay, we are going to see an increase in total revenue. And vice versa, if a price decrease is happening, prices are falling, and demand is inelastic, total revenue is going to decrease. Now, if you can kind of think about why this makes a little bit of sense, goods that are going to be elastic, if you see a small decrease in price, say you're going to put something on sale, if demand is elastic, you're going to see a significant increase in the amount that you sell. If it's inelastic, quantity demanded isn't really going to change as much. So by putting things on sale, you're not really going to see an increase in the quantity demanded, and therefore you're going to see total revenue decrease. This is a perfect explanation, or elasticity is a great example of why gas never goes on sale. Right? You never see a gas station advertise, hey, this week only we're going to buy 1 gallon, get 1 gallon free. Right? There's no incentive to do that because of the inelasticity. Gas is typically inelastic in demand, meaning our tank is only so big, right? And we really drive about the same as we are going to drive, other than maybe if we're going on a trip or something else changes, but really our driving habits stay relatively consistent. And if price falls, like gas right now, I haven't bought a lot more gas at $1.44 a gallon. Hasn't been that cheap in 20 years because I really have nowhere to store it. So really my demand is inelastic. I'm not going out and buying a bunch of gasoline at a lower price. My quantity demand has stayed relatively stable. That makes sense. Okay? And if demand is unit elastic, okay, that means equal to 1 on our elasticity as we calculated last unit. If it's unelastic, meaning a 10% decrease in price will lead to a 10% increase in quantity demanded, they're the same, our total revenue won't change, it'll stay constant. So if we look at how this applies then to the demand curve, the linear demand curve, a demand curve that is a straight line, a lot of our problems in economics are going to be with linear demand curves. We see a constant slope. All right, we see a constant slope throughout the entire relationship of demand. With that comes varying degrees of elasticity. All right, demand becomes less elastic as we move downward. So if you start at the very top, right, or the upper half of the demand curve, you're going to see, demand be very elastic, meaning a price decrease will see an increase in total revenue. However, as we make our way downward, we become less and less elastic. The midpoint, okay, is where we become what we say unit elastic. Now, this graph hopefully help you see that a little bit. Here we have a linear straight line demand curve, meaning equal increments. We're talking about $10 price changes here. So at the very top, demand is very elastic, meaning a small percentage change. You're going from 90 to 100, or from 100 down to 90. You're looking at a 10% decrease in price. Okay? But we're going from a 0 to 100, which is 100, not 100. It's a 0 to 100, or going from 90 to 80, $10 decrease, but it's 100% increase in quantity. So a small change in price, percentage-wise, it's the same dollar amount, but percentage. Going from $10 to $20 up here, this $10 increment, that's 100% increase. 100% increase, but if you come over here, you're going from, right, just 900 down to 800, much less than 100% change. So it's very inelastic down at the bottom, where at the top, the same $10 change leads to a substantially larger, by percentage again, increase in the quantity demanded. So elastic demand on the top half of the demand curve, inelastic demand after we hit that midpoint. So what that means as we move down this demand curve, we're going to see elasticity becoming more and more and more inelastic. So in this range, from $50 to $100, any price change, any price decrease, okay, come over here, any price decrease is going to lead to an increase in total revenue. And you can kind of map that out and see where if you come over and you are at a price of 90, you can multiply 90 by your quantity of 100, okay, and this area is going to be your total revenue. You decrease it by 10, okay, now we got 80, but now we're gaining 100 more units of sales. So our total revenue now becomes this shaded area, a much larger area of total revenue. And you can see the corresponding total revenue curve down at the bottom. And this graph, this line, is representing our total revenue. We peak at 25,000, so at a price of 50, and we sell 500 units, that's where our total revenue is going to be maximized. But these curves are kind of mirroring each other. As we change our output, produce more or sell more of a good, right, our total revenue increases until we reach that midpoint. After that, it becomes inelastic, and as we continue to produce more output, right, we're not gaining that same increase. We're, law of demand, we're increasing sales, just not at a substantial enough rate to make up for the loss in price that we're getting for each unit. So here we see our total revenues start to fall. I hope that helps make a little bit more sense. Come down here. This graph is in your book as well. This will help, I think, kind of get an idea of price elasticity of demand, right? All right, when we are calculating our price elasticity, and that's what we did last week, if our elasticity of demand is equal to 0, we have what was called perfectly inelastic, meaning that a 10% change in price, in this case, is an increase. So price is going up, we know quantity demanded is going to go down. But when it's perfectly inelastic, there is no change. Okay, there is no change in the quantity demanded. All right. What happens to total revenue? Well, when it's perfectly inelastic, we increase by 10% to reflect the 10% price increase, meaning price goes up, consumers are still buying the same. Now that demand curve is perfectly inelastic, is a vertical line. And a good example I can use for this one is my son used to have an egg allergy and he needed an EpiPen. And we had to have 2 of them. So we always had to have 2 EpiPens, one at home, one at school. And you know, they're relatively expensive and they expired, so there was no reason to have more than 2 because they only lasted a few months. And regardless of the price, if the price was $100 for one, or $200, or $1,000, or $2,000, it didn't matter. Our demand was not going to change. We were going to buy 2 over the period that we needed, regardless of the price. Even if they fell to $1, we're not going to buy more than 2 because there's no need unless we use one. Right? We can't store them forever. So our demand there was perfectly inelastic. If your price elasticity of demand is greater than 0 and less than 1, that's what we say is inelastic. That means when we see a 10% increase in price, we're going to see a drop by less than 10% in the quantity demanded. The impact this has on total revenue, it will increase, but by less than 10%. If elasticity of demand is equal to 1, that's unit elastic, that means price is going to mirror quantity demanded. So an increase in price by 10% is a drop in quantity demanded by 10%, and total revenue will not change. When we have elastic demand, our number is greater than 1 but less than infinity. This means it's responsive to a price change. So a 10% increase in price, we're going to see a decrease in the quantity demanded by more than 10%. So if we're dealing with elastic demand, you are not going to want to, as a business owner, drop your price or lower your price because you're going to see a decrease in total revenue. Excuse me, you're not going to want to increase your price because you will see a decrease in total revenue. If elasticity of demand is undefined or equal to infinity, it is what we call perfectly elastic. That means any price change, whether it's an increase or decrease, in this case increase, it's going to drop to 0 and total revenue would drop to 0. That means consumers will not tolerate any price increase at all. So that would be a horizontal curve. Even if I increase by 1 cent, demand would drop, quantity demanded would drop to 0. Hope that helps. Maybe I'll work through a few of the problems from elasticity and total revenue on your homework assignment. That's kind of an explanation of the notes.